Hello, and welcome to this video on predictive coding in IntelliConnect. Predictive coding is a TAR technology. TAR stands for Technology Assisted Review and refers to the use of computer algorithms to identify and tag potentially responsive documents in the review phase of electronic discovery. The benefit of using TAR is that it can help speed up the review process and reduce the review costs associated with large discovery matters. Predictive coding was added to IntelliConnect in version 2.4. Because the predictive coding process is complex and can vary for different data sets and matters, it is difficult to show a real-life demonstration of how predictive coding works in IntelliConnect. In addition, you really need to have a good understanding of the case and data set to fully appreciate the results that you get using predictive coding technologies. That said, we do have a predictive coding white paper entitled Understanding Predictive Coding Workflows Using IntelliConnect. This white paper walks through a predictive coding exercise and highlights the time and cost savings for a given data set. This is available on our website. In this video, we will discuss the predictive coding workflow used in Connect and the different steps that make up the workflow. We have a small sample data set that has been prepared for this demonstration. This allows us to easily demonstrate the concept. We will talk more about that later in this video. IntelliConnect utilizes a continuous active learning approach to predictive coding. This is also known as TAR version 2. Continuous active learning is a machine algorithm that regularly analyzes users' decisions in order to rank unviewed data based on the user's previous decisions. We use a workflow for predictive coding in IntelliConnect. The workflow is shown in this image. You can see that there are 7 steps in the predictive coding workflow. Note that there are some steps in the workflow where you may need to move back to a previous step. We will talk more about that later. Let's look at the workflow in more detail. As noted in the above-mentioned white paper, one of the biggest areas of potential failure in predictive coding projects is the failure to identify an appropriate starting candidate data set for use in the predictive coding exercise. Predictive coding algorithms are almost never applied to an entire document collection. If we think about it, the predictive coding part of the e-discovery matter is one piece of the puzzle. It is primarily used in place of the traditional method of manually reading all potentially relevant documents and coding them appropriately. When you are dealing with hundreds of thousands of documents, the traditional review and coding of all potentially relevant documents is a time-consuming and costly exercise. One of the main reasons why predictive coding is used is to reduce the time and cost for the review and coding stage of the discovery. Note that I said the review and coding of potentially relevant documents. This leads us to the first step in the predictive coding workflow, which is data preparation. Predictive coding is designed for coding documents that have been identified as potentially relevant. Therefore, it is implemented at the stage when the data set is ready for review and to be coded. To get to this stage, the data has to be prepared. Data preparation has 3 parts. Firstly, the process of using searching techniques to identify the potentially relevant items for the review. This may include using search criteria such as keyword searches, date range filters, file type filters, etc. Secondly, the process of culling and excluding problematic file types. Culling items from the dataset which are clearly not of any value is a must. These may include items such as images, containers, empty documents, website types, etc. In addition, we need to exclude item types that can be problematic to the predictive coding process. Here are 2 examples. 1. Items such as spreadsheets are not well suited for textual analysis. These file types can introduce thousands of small text tokens or cell values, which are likely not repeated in any other document. While predictive coding could correctly classify these items, including types like these would make the task so much harder for every other document. This is because the predictive coding model will need to check if other documents also contain those cell values. The probability of other spreadsheets having this data is low, but it comes at a huge processing expense. In these cases, manual review and coding are recommended for these file types. 2. Another example is when documents contain a lot of pure text. These documents can contribute a lot of terms to the predictive coding model, which can affect performance. These items should also be manually reviewed and coded. Note that running the predictive coding algorithms is a resource-intensive process. All efforts should be made to remove such items so that the predictive coding process can be run in the most efficient manner. The third part is in relation to the deduplication. Deduplication should also be performed when preparing the data so that the predictive coding engine does not have to compare the text in all duplicates. This will greatly improve performance. The user can go back and tag the duplicates accordingly once the predictive coding process is complete. Once the dataset has been searched and filtered to contain only potentially relevant items and cleaned to remove potentially problematic files, this is what we call the review set. This would typically be the set of documents that you would review and code using the traditional manual review and coding methods. It is at this point that we can start the predictive coding process. There are two setup tasks that we need to do before we look at running a new review, which is the second step in the workflow. The first task is to create tags for the coding decisions. The second task is to create a coding layout for the predictive coding model to use. For this demonstration, we don't require many tags. This setup consists of a top-level or parent tag called responsiveness. Under this parent tag, I have created two tags for responsive and non-responsive. These are the tags that will be used to hold the coding decisions. Note that for the purpose of this demonstration, responsive and non-responsive are synonymous with relevant and non-relevant. You will notice that I also have a tag called helper, which has subtags. These tags are only here to show how the predictive coding model is learning for this demonstration. You don't need to make these tags. In terms of the coding layout, all you need to do is create a simple coding layout that supports the responsiveness tag and its subtags. Again, the helper tag is for this demonstration only and does not need to be added to the coding layout in a real case. I will talk more about the helper tags later when we look at the learning phase. The second step in the workflow is to start a new review. This is where you start the predictive coding process in Connect. Creating a new review is a setup process that has a number of settings that need to be considered. To get started, we need to point Connect to the review set that we got from the data preparation step. The review set tag is searched and the items are highlighted. We right-click on the highlighted items and select the predictive coding option. This opens the wizard to start a new predictive coding review. Enter a name for this review. Next, we need to select the coding layout that we created for this predictive coding workflow. In the category field, use the drop-down and select the responsiveness tag. The engine will use this field to categorize the items in your review. This tag should only contain two possible options or subtags. As you will recall, the responsiveness tag has subtags called responsive and non-responsive. The setting for the primary option is one of the tags under the responsiveness tag. This field will be considered as the category of your prime interest. For example, this is usually responsive as we typically want to identify the responsive items in our review set. It is important to select the right option here as the entire review will be optimized to find items later coded with what you have entered for this option. In this case, I will set this to responsive. There are also some advanced settings available. The first shows that there are two predictive coding algorithms to choose from. One is considered faster but less precise. Reviews using the other more accurate algorithm may have better quality, but they can take 3 times more time to prepare and evaluate. You can read more about the algorithms in the Connect user manual. The second advanced setting allows you to set up the maximum number of CPU cores to be used for the predictive coding process. You should choose a reasonable number of physical cores as processing for predictive coding is resource-intensive. That said, you should not set this to all of the cores in the system as the operating system and other applications require cores to operate as well. Finally, you can choose whether to use existing coded documents as a kickstart for the initial learning stage. This will be discussed more in the next step of the workflow, but for now, we will leave this turned off. Once the fields in the wizard have been populated, click on the Start in Background button at the bottom of the screen to start the new review process. During this process, the predictive coding engine will prepare your review and it will also create the model which will be responsible for making future relevancy predictions. Note that this operation is very resource-intensive and requires a considerable amount of processing power in regards to CPU, RAM, and disk. More details about this can be found in the Connect user manual. You can see the progress by clicking on the Review tab, then clicking on the Predictive Coding option. The next step in the workflow is initial learning. The initial learning stage is when the engine looks for the best items to kickstart the learning process. There are two modes for initial learning. The first mode is existing tags. The user can use existing tags for items that have already been reviewed and coded in the case. This setting is set in the New Review section in Step 2 of the workflow. In this case, the learning algorithm is updated based on the coded items, and there is no requirement for manual coding of items to update the algorithm, or what we call the model. When using existing tags, the learning for the model is conducted on both items which are tagged as responsive and non-responsive. The best way for the model to learn is to have an equal mix of both responsive and non-responsive items for the existing tags. If that is not possible, you need to make sure that existing tags contain at least 20% responsive items. Only use one category of tags. For example, items tagged as either responsive or non-responsive should be avoided. The algorithm learns with more accuracy when it has an even sample of both responsive and non-responsive items. The second mode for initial learning is learning while manually reviewing and coding documents. In this mode, existing tags are not used. Instead, the user reviews and manually codes items. When the items are coded by the user, the model learns the user's decisions and determines which items are similarly based on those decisions. This happens in real time. Therefore, the model is updated on the fly for each item which is coded relevant by the user. For this demonstration, we have not used existing tags and we will manually code documents for the initial learning step. After the initial processing for the new review has been completed, a new panel in the Review tab will appear representing the newly created review and informing you about its current state. The panel for an ongoing review contains the following information. The review name is the name you assigned while creating the review. This button can be clicked to display the Predictive Coding Quick Reference. This is easily accessible documentation that may be useful when learning how predictive coding works. There are two configurable charts that show some essential information about the state of the review. They will be populated with data while the review is underway. The Total Items field shows the total number of items for which this review was created. The Coded Items field shows how many items have been coded in this review. This number includes the coding decisions made by human reviewers, as well as predictions applied by the engine when the review has been completed. The Responsive field shows how many of the coded items have been designated to be responsive. Note that this field will match the primary option which you selected when creating the review. The Non-Responsive obviously shows how many of the coded items have been designated to be non-responsive. Again, this field will match the opposite to the primary option which was set in Step 2. Now that the review has been processed and created, we can start the review and coding phase, which is part of this initial learning step. You can do this by either clicking on the Start Review button at the bottom of this panel, or you can click on the New tab at the top which has been created for this review. Connect will show a similar screen to what you would see when reviewing batched items in the Review tab. At the top right corner, you will see an information panel that provides live updates regarding the review process. In this case, we can see that we are in the New Review mode. Note that this information will automatically update and change as you start to review and code items. The initial learning process that occurred at the start of Step 3 has discovered the best items to kickstart the learning process. The results are shown on the left as what we call the document or item queue. Before we move on, I mentioned earlier that I had also created some helper tags. You can see these tags here in the coding layout. You can also see that the items in the queue on the left are also tagged with these helper tags. As mentioned earlier, these tags are not part of the predictive coding process. In this case, we have already tagged the items in the queue with these helper tags to help us explain and show you how predictive coding works in this demonstration. You do not need to do this in a real case. The helper no tag is the equivalent to the non-responsive tag. The helper yes tag is the equivalent to the responsive tag. For demonstration purposes, These tags allow us to code documents quickly without having to read through the content for each item during this next stage. Now we can start the manual learning phase. During this phase, you simply review and code documents in the queue as you would do during a normal review. In this case, the helper tags let me know which items are responsive and non-responsive so I can code them quickly. In a real case, you would review and code the items accordingly. Here is a coding feature that can save you a lot of time. I'm using a quick method of applying the coding decisions. Instead of clicking on the coding option and then clicking on the Apply button to code an item, you can select the coding option and then press the spacebar. Pressing the spacebar will apply the coding decision to the item and it will move on to the next item automatically. As mentioned, this method would save you a lot of time and clicks on larger review sets. Now that I have started to code items from the queue, you can see that the information panel has now changed to Initial Learning. The model has initially selected a number of items to be manually coded. You can see how many items are left to code for this initial learning phase in the information panel here. Note that if the model does not have good information when you have coded these items, it will go into another round and you will be given more documents to code. This can happen several times depending on how well the model is learning. You will also notice that the queue on the left jumps around a bit. This is because the model is learning for every document that is being coded. The model tries to find responsive items based on your coding decisions with each document. This causes your place in the list to change as it moves to the next item that the model thinks contains some unique information. I will continue to code more documents. Once the model has a reasonable level of representation for both responsive and non-responsive items, it will automatically switch to the active learning mode. This is step 4 in the workflow. You can see that the information panel has been updated again to reflect this. Also, in the active learning mode, each item in the queue now has a score of what percentage the model thinks the item is likely to be respondent or non-respondent. The queue is ordered with the highest percentage at the top. At this point, you continue with reviewing and coding the items in the queue. The queue will start to become much more organized and you should start seeing items with the highest relevance scores at the top. For each item that is coded, the model is continuously learning. Like before, there will be times when the queue will be updated and the list will change. In this example, we have just coded a number of items that are responsive. Now the queue has been updated and it shows a number of non-responsive items to be coded. This continued balancing of coding both responsive and non-responsive items increases the accuracy of the model for predicting responsiveness for the items in the review set. Here is another tip. If you have made a coding mistake, you can click on the button next to the Actions button. This will open a panel that will show you the recent coding history. Clicking on an item number will take you back to that item in the Review tab where you can apply the correct coding. As we continue coding, the million-dollar question is, when do I stop reviewing and coding documents for the active learning step? Unfortunately, there is no exact answer to that question. However, there are a few indicators that will give some assurance that you have coded enough items to move forward to the next step. One indicator for having coded enough items is that you start seeing less responsive items over time. Typically, you would initially see a lot of responsive items and that will taper off as you code more of these items. This is an indication that the model is working well and it is running out of responsive items in the review set. In this example, we have not seen items that the model predicts as responsive for some time. That means that we have likely coded all of the responsive items already. Note that for this demonstration, I am familiar with this data set, and I know for a fact that all of the responsive items have been coded in this example. Keep in mind that this is a small sample data set designed to show you how predictive coding works in Connect. In a real case, the review set could consist of many thousands of items, and you would likely not review and code all of the responsive items before you move to the next step in the workflow. A second indicator is that there will be a large gap between the items that are respondents and the items which are non-respondent. In this example, you can see that the lowest percentage score for the respondent items is 90%, whereas the highest percentage score for the non-responsive items is 34%. That is a gap of over 50% between these categories. The larger the percentage score gap between the respondent and non-respondent items, the more confidence you can have for stopping the active learning phase and moving into the next step. There are also other factors for why you may stop the active learning review and move to the next step. One is when you have achieved the desired recall level in the illusion test. We will discuss illusion tests next. Another factor is when you have met other metrics for your project. For example, you have reached the time allocated for the project. Once you have reached a point where you are confident that you have reviewed and coded enough items for the active learning step, click on the Predictive Coding tab. This will display the results of the learning iterations that have taken place so far. This is where we move to the next step in the workflow, which is the illusion test. An illusion test helps to identify what we call blind spots in the model. For example, a low number of respondent items in the last few iterations of active learning may simply be due to the predictive coding model not having seen a particular subtype of respondent documents. The illusion test adds a level of safeguard to minimize the risk of these items being overlooked. This is done by the user reviewing and coding a number of items that are randomly selected. When you start an illusion test, the system will select a random sample of the non-coded items in the review set for you to review. Once the items have been reviewed and coded, it will measure and estimate how many non-coded respondent items could potentially be left in the review set. If there is a large number of respondent items identified based on these results, you can go back to active learning and perform more review and coding to strengthen the model. On the other hand, if there are no items or a low number of items identified, then you may choose to accept the model and move to the next step in the workflow. Click on the Start Illusion Test button to get started with the illusion test. The illusion test can be run in one of two sampling types, either fixed size or matching statistical criteria. This will determine how large the sample set will be for the illusion test. The fixed size option is typically used for understanding how the illusion test works, or to run smaller, more frequent checks on the unseen portion of the review set after each review, coding, and learning iteration in the active learning phase. It is recommended to select the Matching Statistical Criteria option for the illusion test when running predictive coding on a real case, as it will produce defensible statistics on the achieved recall. When selected, the Matching Statistical Criteria option shows two more settings to be configured for the illusion test. The Desired Recall option helps you to set the minimum recall for items matching responsive, which is the primary coding option that we set. The larger the value you provide, the more items you will be asked to review and code. You should set this at least to the minimum recall level that is defensible for your project. For example, this value may be driven by external factors such as a court dictating that the recall level must be at least 80%. The recall is the ratio of responsive documents in the review set that your workflow has managed to collect. For example, the desired recall of 80% means that you allow 1 out of 5 responsive documents in your review set to be overlooked. The Maximum Eluded Items Allowed option tells the engine how many responsive items you would allow to be found during your illusion test. A perfect predictive coding model would make no mistakes, so this value would be 0. However, in real-world projects, achieving perfect accuracy is rarely the case and is usually not possible. In real-world projects, some prediction mistakes by the model are to be expected. This setting works in conjunction with the recall setting. For example, if you set this value a bit higher, then even if you find that many relevant items during the illusion test, you will still meet the minimum recall criteria which you set. Note that to still meet the recall, the number of items that you will need to review and code in the illusion test will increase the more you increase this value. Obviously, lowering this value will cause the illusion test size to shrink with fewer items to review and code. But if you find too many relevant items, then the test will never reach the minimum recall. We have both the recall and maximum eluded items criteria because different projects may need different ways of how you measure quality. Short of reviewing and coding every single document in the review set, prediction mistakes will likely be made to some degree. These settings allow us to set a defensible level for how many respondent items we are allowed to miss. As mentioned, the minimal allowed recall may be dictated by a court. In this example, I will set the recall to 70%, and I will set the maximum eluded items to 2. Note these are just settings that I have used for this demonstration. These settings could be different for each case that you run predictive coding on. Once you have set the sliders to the desired position, click on the Start New Test button, and then click on the Continue Illusion Test button on the Statistics page to start the test. This will bring you back into the Review tab. The items required for the illusion test, based on where you set the sliders in the setup screen, are listed in the review queue on the left. Note that these items are a random selection. We have stepped past the learning phase, and we are now trying to find items that the model may have missed. Also, note that these items are listed in random order. You can tell by the percentage scores being in random order. From here, you just review and code the documents as normal. To save time, I will code these items off-screen. As you can see from the message on the screen, I have now coded the items in the illusion test. When I click on the Go to Reviews button, it takes me back to the Predictive Coding page. Now we can click the Finish Illusion Test button to view the results. Looking at the numbers, we did very well. We set the recall rate for the illusion test to 70%. The results show us a recall of between 79 to 100%. This means that with a confidence level of 95%, we are guaranteed that our recall on the entire data set is at least 79% and could be up to 100%. In fact, in this example, the recall is actually 100%. I know this because I know this data set, and I know we have coded all of the responsive items in the data set. At the bottom of the screen, we are asked how the results from the illusion test should be applied to the review. Of course, this decision depends on the results. The first option is to accept the model. Because we got a high recall rate from the illusion test, we can be confident that the model has reached the desired quality, and we would select this option. The second option should be selected if you did not meet the recall threshold that was set for the illusion test. This would likely be because more respondent items were discovered in the illusion test, and the number of respondent items exceeded the maximum eluded items allowed option, which was set for the illusion test. In this case, the model has not reached the desired quality, and you will be taken back to the active learning step. More items will need to be manually reviewed and coded by the user to strengthen the model and improve its quality. As I said, we have exceeded the recall threshold, so we will accept the model. This completes step 6 of the workflow and takes us back to the Predictive Coding page. Once the model is accepted, its state cannot be changed. We now move to the last step of the workflow, which is completion. In this step, the Apply to All Items button will be unlocked, so you are able to apply the model's predictions to the remainder of the review set. Applying the model to non-coded items is a pretty straightforward process. Since our model can tell us the relevancy score of each item in that pile, your job is to indicate what threshold to apply. The threshold is where we qualify everything above as respondent and everything below as non-respondent. The threshold that you select will depend on the distribution of relevancy scores in your model. It is about finding the large gap between the responsive and non-responsive items, reading what relevancy scores are set for those, and setting the threshold to the highest value which separates the two. For example, if the highest non-responsive item was 30% and the lowest responsive item was 70%, this setting could be set to 65%. Note that this example is a perfect case that has a large contrast or gap between responsive and non-responsive items. But in other cases where the gap is not so large, you may need to set this differently. You would do that by analyzing the relevancy scores for the model. In commercial cases, once you have completed the predictive coding exercise, you would of course follow any other steps or workflows that you have in place before disclosing the respondent information. That completes this demonstration of the predictive coding workflow in Connect. As mentioned at the beginning, we have a predictive coding white paper available if you require more information. This white paper runs through a predictive coding exercise and discusses the results and cost savings.